Have you ever wondered how fast sound travels and what affects its speed? Well, to answer that, first imagine sound as a wave moving through a medium, like air or water. The speed of sound is essentially how quickly this wave moves. It's influenced by two main properties of the medium: elasticity and density. Elasticity is the medium's ability to resist being squashed and then spring back, much like a rubber band. Density, on the other hand, is how much stuff or mass is packed into a certain space. The more stuff there is to push through, the slower the sound wave travels. There's a neat little equation for this. The speed of sound equals the square root of gamma times pressure divided by density. Gamma is just a constant that depends on the gas we're dealing with, about 1.4 for air. Now, let's delve into some factors that can affect the speed of sound. First up is temperature. When the temperature rises, the air becomes more elastic as molecules move faster and crash into each other more. At the same time, the air becomes less dense as gases expand. The result? Sound zips along faster. For instance, on a scorching day, sound can travel at about 349 meters per second, while on a freezing day, it slows down to about 331 meters per second. Next, consider pressure. Surprisingly, as long as the temperature stays the same, pressure doesn't significantly affect the speed of sound. It's because pressure increases density, but it also affects elasticity in the opposite way, so the two effects roughly balance out. Humidity, or the amount of water vapor in the air, can slightly speed up sound. That's because water vapor is lighter than air, adding mass without significantly affecting elasticity. Interestingly, the speed of sound doesn't care about the frequency of the sound wave. So, a high-pitched sound and a low-pitched sound will travel at the same speed through the same medium. Wind can influence the speed of sound too. If the wind is blowing in the direction the sound is traveling, it will give the sound a little speed boost. But if the sound is moving against the wind, it will slow down slightly. So there you have it, a crash course on the speed of sound and the factors that influence it, from the temperature of a guitar string affecting the pitch of a note to the way fog can slightly alter the speed of sound. It's a fascinating world full of sound and fury, and now you know a little more about how it all works.